All right, so lesson 5.4 is compound inequalities. So we have a couple definitions for today. The first one is for compound inequality. I will try to write this neatly. It is two or more inequalities connected by the words and or. Okay, so there are two ways to make a compound inequality by the words and or. So we're actually going to look at those two right now with intersection and union. So intersection is a compound inequality with the word and. Okay, the graph, because we're also going to be looking at graphs today. So the graph is the solution of elements in common, elements in common in both sets. All right, so what values do both inequalities have in common? All right, so intersection is the word and. We're just going to write that over here to remind ourselves. That means union must be the word or. All right, so union is the graph of the compound inequality containing or. It's the solution of either inequality. So one way I like to think of this, if I brought into school cookies and cupcakes, okay? And I said, you can have a cookie and a cupcake. That means you would get both of them, right? But if I said you can get a cookie or a cupcake, that means you only get one of those two things. All right, so let's take a look at the first example. It is just asking us to graph the solution set of y is greater than or equal to 5 and y is less than 12. All right, so I'm going to put a nice big number line here. Again, we don't need a ton of numbers on here. We know we need to have 5 and 12 at least, but we're going to add some other numbers. So your number line must be oriented correctly. Think way back to elementary school. Smaller numbers on the left. So 5, not negative 5. So 5 needs to be on the left, and 12 needs to be somewhere on the right. And then just pick a value to the left of each, and then one in the middle. So I'm going to do 4. I'm going to put 9 in the middle, and 13 on the right, just to give us a few more numbers. All right, so now it says y is, actually I'm going to use a highlighter, y is greater than or equal to 5. So that means a closed circle at 5, and it is going to be shaded to the right. Okay, then we're going to pick another color, so it might be helpful if you have two colors today. Less than 12. So that means an open circle at 12 and everything shaded to the left. All right, so if we just wanted to look at our final answer, actually let me get a brighter color. Our final answer would be a closed circle at 5, an open circle at 12, and everything shaded in the middle, because that was the only place my two highlighted answers overlapped. And remember we said that n is what they have in common, and they shared all those numbers in common between 5 and 12, including 5, but not including 12. All right, take a moment, try the your turn, and graph that solution. So you can see for this answer, I just graphed what the answer is. So I'm actually going to show you how I do this sometimes. So that way I don't have to make a whole bunch of lines. All right, so for this, I'm just going to go ahead and put two small ones. So I'm going to say, okay, greater than 6. That's an open circle, and it's going to be shaded that way, okay? And y is less than 10, well, that's going to be a closed circle, and that's going to be shaded that way, so then I can clearly see they're going to overlap just in the middle, so that you don't have to have all of that. But by all means, if you like to do it like I did for example 1, please feel free to do that. All right, we have example 2 now. So now we have to solve something first and then graph the solution set. So this is what a typical compound inequality looks like. It has two inequality symbols smashed together. So I'm going to show you how to solve it if it looks like this, and then off to the side I'll show you how we can break it apart and solve them if that makes it a little bit easier for you. So I'm going to go ahead and rewrite this. All right, so my z is right there in the middle, so I still want to get that by itself. So to get that by itself, I would need to subtract 2. But now I don't just have one side of my equation, I have two sides. So I need to subtract 2 from all three places. I need to subtract the 2 to eliminate it with the z, and then I need to subtract it to the right side of the inequality and then to the left side. So 7 minus 2 is 5, which is less than z, which is less than or equal to 11. So if we just look at that, we're good to go. This is actually, I'm sorry, I wrote 11, and 11 minus 2 is not 11. Here we go. So z is less than 9. That looks a little bit better. So now we can graph this, and I sort of like leaving it as a compound inequality because think about it, z is in between a 5 and 9 with my inequality symbols being less than. So that means if I have 5 and I have 9, we'll put a couple more on here. That automatically tells me that I'm going to be shading an open circle at 5, a closed circle at 9, but everything in the middle. Okay, so with this, I want to go ahead and say that if you have the inequality symbols less than or equal to, that in our compound, actually, I'm going to hold off on that for a second. Hold off on that. Don't want to get ahead of myself. All right, so I'm going to erase my graph now and show you how you could separate them if you needed to. All right, so if we needed to separate these, the first one will be just the left side of the inequality. So 7 is less than z plus 2. And my second one is going to be z plus 2 is less than or equal to 11. So now I have two inequalities that I can solve. So I'm going to subtract 2, and I get z is less than or equal to 9. And then over here I'm going to subtract 2. There's a chance my marker died. So over here I'm going to subtract 2. And I get 5 is less than z. So if you look, and sorry, I erased my 9 accidentally. If you look, we ended up getting the same answer, 5 is less than z, and z is less than or equal to 9. We got both of them. So go ahead, try the your turn, and then come back and solve. All right, so for that your turn, you can see that you should get x is between -1 and 7, not including either endpoint. All right, so this is going to be interesting now. All right, I think I got it figured out. So a ski resort has several types of hotel rooms and several types of cabins. The hotel rooms cost at most $89 per night, and the cabins cost at least $109 per night. Write and graph a compound inequality that describes the amount that a guest would pay per night at a resort. So we have two different inequalities here we're looking at. And it's not letting me draw with my touch. Let's try this again. Oh, there we go. So we are going to say that x is going to equal the amount of money we are spending per night. So the money spent per night. All right, so we have the hotel rooms cost at most $89 per night. So that means $89 is the most I'm going to spend. So that means it would be less than or equal to x. And then we have the cabins cost at least $109 per night. So if it's at least, that means, wow, we could end up paying more than $109. But now we need to think, should I put an and or an or between these two? So think, can you sleep in a hotel room and a cabin at the same time? And your answer should be no. We can either sleep in a cabin or sleep in a hotel room. So we have or in the middle of that one. All right, take a moment, try the your turn, and then come back. All right, so after reading the problem, it looks like you would spend less than $65 on a seat, or you would spend $80 or more on a seat. All right, so moving on to example 4. We have to solve these. Now, these are two separate inequalities, but they are connected with the word or. Okay, so we're going to have to solve each of them and put that or in the middle. So I'm going to try to rewrite them, and I apologize, this is not as neat as before. So we have to add 7 to both sides. So we get 4k is less than or equal to 32. And then we have to divide both sides by 4. So k is going to be less than or equal to 8. For my other one, if I subtract 12 from both sides, I get negative 9k is greater than or equal to 18. And then divide both sides by negative 9. So I'm flipping the sign, and k is less than or equal to negative 2. Now they had the word or in the middle. Now we get to graph each of these. So I know I have a positive 8, I have a negative 2. I'm going to go ahead and just put those on there for now. So I have xk is less than or equal to 8. So I have an open circle there, shaded to the left. And I have k is less than or equal to negative 2. So close circle there, shaded there. Now, if this were an or statement, my final answer would just be from negative 2 to the left because that is the region that both of them are shaded. But since it's or, looking at this right here, this is my answer. Technically, it would be anything from 8 to the left, so anything less than negative 8, because the negative 2 is also included in there. All right, so take a moment, try this last your turn, and then come back together. All right, so you can see what your graph should look like, what answers you should have gotten. In case it's a little tricky to read, you should get x is greater than